The Earth Science Classroom, Top 5's. All right, now we're looking at the Earth's interior and from a teaching perspective. So how are we going to teach this to our students? Now, our students could have a background of science in high school. They could be doing this as a freshman level class, an entry level science class, not the highest, not the lowest, but the students could have a good deal of background knowledge to do this or not. But I like to always start with a lot of intro videos showing how the Earth's um, crust is, and maybe a video. So I introduce it with videos as an introduction, something to get their attention, and maybe a video on the Kola Deep Bore project in Russia. This is a project that lasted about 3 decades due to different, couldn't get financing because of different issues within the country and the corporations, and it was very expensive. And they wanted to drill as deep as they wanted to, deep as they could into the crust, hopefully down to the mantle. But they actually got about 12 kilometers down, with plans to go even further. But that gives you kind of like the idea of how hard it is to go to drill inside the Earth. So hopefully get the kids' attention with that. And then I would move on to number 2. I'd move on to doing the poster project. And this would be like ongoing, either as a homework assignment or maybe part of the class is dedicated to a certain section of the project, but I would break it down into sections. Section 1 would be the poster, the drawing the poster, outline the poster. So I would get the depth. So I would look at the physical layers. So there are 6 of them, and I'll get a 18 by 11, or if I can get hold of a larger size paper for the students, the bigger the better, because the larger they can draw this Earth's interior, the better. So I would do it like this, like a big pizza slice. So here's my poster paper, and I'll do this big like pizza slice, so like this, and I'd get the students to measure from, like, this red line is the ruler, measure down here, and this would be my depths, and I would get the kids to mark off the different depths of the different layers that they have researched. So there's a little bit of research in there, a little bit of internet research to find out the depths. You can do it in kilometers or miles. It doesn't really matter. Depends what the internet sources state. And I would have them obviously draw parallel lines, horizontal lines, and I would have them, so first draw, then I would label, and then have them write down different characteristics and different facts about each of the layers, the composition, the density, the pressure, temperature. You could even have depth down here on this axis. You could have pressure over here. You even have a line that you set out for the geotherm as well. And then on the back of the poster, I would have questions. So I would set, like, say, 2 or 3 analysis questions. So I would do like a question on the different crusts. So ocean crust versus continental crust. I would do a question research on the moho. What is it? Why is it a certain depth? Who discovered it? What's the importance of this this discovery? And then I would also do the EM field, the generated geodynamo from the outer core, and they would start to look into the outer core being liquid and the iron alloy that is moving, which creates this field. And they would start the research, and this would go along with the lessons. Let's say this is a 5 to 6 lesson project, or maybe 2-week project, but they have time to research and complete these posters. I tend to do this individually, but you can do it as partners or small groups. Depends on your classroom, depends on the level of students. If they are more comfortable with the level, then it's individual. If they need a bit more teamwork, cohesion, then obviously group work would be better suited. Next thing I would do, I would focus on the seismic waves. Now, whether you've touched on earthquakes before or had some physics before, so if you haven't, you can still discuss these waves that are generated from earthquakes and the body waves, the P and S waves, are going to propagate or travel or move through the Earth's interior all the way through. Now, there's some refractions, there's some deflections, there are some change of speeds, but the students have to understand that this is how we figured out the Earth's interior, by looking at this indirect evidence of the seismic waves as these guys go through the Earth's interior. Now, I use slinkies, or I use some jump ropes, or I use a larger rope from my phys ed department that I would use to demonstrate how these waves move and propagate. I can even do the basics of, the wave anatomy, or the profile of a wave from crest to trough and how it propagates in a certain direction. And you can also look at the set velocity of these waves through different mediums. So states of matter, and also you can bring in different densities. As the Earth's interior, the Earth is pretty much a pretty much 99% solid rock. The different kind of rocks and densities would affect how fast these waves go, and that's how these scientists figured out the Earth's interior layers. Next, I would do a jigsaw activity, where I would separate or divvy up the students into groups. I would assign a particular layer or a particular topic within a layer, and I'd have the students research, discuss, collaborate, make notes, complete worksheets, even design something to show or present to the other groups, and I would have group work. And I have a lot of collaboration, and at the end of the day, they would present all this information onto either a Jamboard or a poster presentation around the room, and we discuss each layer and how they interact with each other, or what is different about them. So you could do similarities and differences. And this would also link back to the poster project and add more information for that. Then my last main activity for the Earth's interior would be focusing on the crust. So I'd focus on the crust, I would focus on the materials that we use, we utilize, we excavate, we mine. You could do a section on mining. There are awesome, huge mines both in the US, Australia, Russia, mining for sulfur, copper, gold, diamonds. I mean, in terms of Africa, you do some geography, some social science with that. You do some history with the gold rush in the western states, California, the Yukon, up in Alaska, and Canada. And you could do ores versus minerals, and bring that back to minerals. If you haven't done it before, or you had done it in previous lessons, you could bring that back into it. You could even do gemstones and all these things that could link up the crust, things that you use, like even the elements and minerals in cell phones comes from, a lot of it comes from the ground. So we can link up that way, so it's more tangible and not as abstract as saying, oh, the inner core is 4,000 miles below our feet and millions of pounds of pressure. Most students can't even think about that kind of information. They need something more hands-on, so they can appreciate and see with their own eyes. All right, so hopefully this helps everyone out. There's more. These are the top 5's that I really work with to introduce the Earth's interior. There are other things that I may delve into in the lessons. All depends on how we get through each lesson and the progression of each student. Need anything? Any comments you may have about the Earth's interior teaching lessons, pedagogy, methodology that I use? Please let me know in the comments. It'd be great to hear from you and read about them.